Hello everyone, welcome back to our channel. Let's discuss some of the problems which are related to the mass spectrometry. See the first example, it is an amine. We need to identify the different peaks for this particular compound. So how can we do the fragmentation procedure? We know that in case of the amines, we are having a lone pair electron on the nitrogen atom or not. Simply removal of a single electron produces what? Molecular ion. This is the what? Molecular ion. The molecular ion M by Z is what? 101. So initially what we are doing? We are doing beta homolysis. See this one with respect to nitrogen, this is alpha, this one is beta. Removal of hydrogen radical. Hydrogen means 1. So 101 minus 1 means we will come up with what? 100 or not? So the second peak. We all know that onium fragmentations in case of amines. The onium fragmentation takes place here. Transfer of beta hydrogen from the beta carbon to nitrogen followed by alpha cleavage. See this one, what happens? The H is coming here, thereby we are getting what? This kind of space. The peak is 58. So 58 done, 100 done, 101 done. Now see this one. Here we have done the beta homolysis. If you do beta homolysis here, what happens? CH3 radical will be removed or not? So 101 minus 15 means we will come up with what? 86. So the 86 peak will appear. So this radical and this radical can form a pi bond. So this can also involving in the onium fragmentation. Transfer of hydrogen from the beta carbon to the nitrogen atom followed by alpha homolysis. Thereby we are creating an ion that is 44. So in this way we can identify different peaks of a particular compound. Okay. See the next example, benzyl alcohol. 108, 106, 105, 79 and 77. In case of the benzyl alcohol, we need to identify 108, 106, 105, 79 and 77 peaks. We know that this is the structure of the benzyl alcohol on 108 and 106. What is the difference? 2 or not? That's why we need to remove 2 hydrogens. M minus 2 peak. Already we had a discussion on the primary alcohols. M minus 1, M minus 2, M minus 3 peaks. So here it is the M minus 2. 108 minus 2 hydrogens means 106. Beta homolysis we have done. Here it is beta homolysis. This is alpha homolysis. Okay. Later what happens? This is a carbonyl group or not? Aldehyde or not? In aldehyde we are doing what? Homolytic cleavage. Alpha homolysis. So H radical removed means 106, 105. Now removal of CO by the hydrolytic cleavage. You will come up with 77. If the 77 is subjected to further cleavage, C2H2 takes place. We can also get this kind of space at M by Z 51. Okay. So 108, 106, 105, 77. The last one is what? 79. How can we observe the 79? See this one. Here what we are doing, we have formed the molecular ion at the pi bond. Then we are doing the beta homolysis. H radical removed, we are getting the H or not? This radical and this radical can form a pi bond here. This is involving in the conjugation. So this positive charge shifted to this carbon. See this one. Already we know that if the benzylic carbon is getting the positive charge, we can create or we can rearrange it into a tropylium cation or not. See this one, it is converted into a tropylium cation and we are having OH. So here this positive charge is shifted to this carbon, thereby we are getting an enol. The enol is subjected to ketoenol tautomerism, thereby ketone is produced. Remove CO. You will get the peak 79. So in this way we are creating 108, 106, 105, 79 and 77. Sometimes in mass spectrometry you will get the questions like this. Differentiate between two compounds. Differentiate between two compounds. These two are the ketones or not? The molecular weight is same but the linkages are different. So let us see the different peaks of these two compounds. Already we know that in case of the ketones, what we will observe? 2 times alpha homolysis, 2 times alpha hydrolysis. If we have the gamma CH function, we will be having McLafferty rearrangement. See this one. This is alpha homolysis, CH3, CH2 radical is removed. So this is 105. Elimination of CO 77. Elimination of C2H2, 51. Next one. Heterolytic cleavage, CH3CH2 plus and C triple bond O radical. Next, homolytic cleavage, benzene radical and this ion. See this one with respect to this pi bond, alpha, beta, gamma. So involving in the what? McLafferty rearrangement. Here 106 peaks. So finally 134, 105, 77, 51, 29, 57, 106. These many peaks will appear for this particular A compound. In case of the B compound also similar kind of situation. Alpha homolysis, removal of CH3 radical 119. Alpha heterolysis, CH3 plus you are getting. Next, alpha homolysis, benzyl radical removed and CH3 C triple bond O plus. Next one, alpha heterolysis, CH3CH2 plus. Here remove the CO, benzyl cation, converted into tropylium, 65 and 39. So finally we are observing what? McLafferty rearrangement. Due to the McLafferty rearrangement, we are getting the peak that is M by Z 92. So finally, how many peaks we are getting? 134, 119, 91, 65, 39, 15, 43, 91 and 92. So in this way, we need to differentiate the compounds by using the mass spectrometry. So these are some of the examples. So you can take different textbooks and try to solve the different problems based on the fragmentation procedures. If you have any kind of doubt, please do comment on the comment box. I can give the reply.